The T-54 rolled out in 1947. 36 tons of steel, 100 millimeters of angled frontal armor. It packed a 100 millimeter D-10T rifled gun. This completely outgunned early Cold War NATO armor. Its 2.4-meter height profile reduced long-range hit probability by nearly a third. But that low ceiling exacted a harsh penalty. The turret space was brutally cramped. The loader had to operate bent over, dropping the combat fire rate to a sluggish 4 rounds per minute. The real deal breaker? Zero radiation shielding. A 1953 nuclear test proved the steel hull survived a blast, but the crew inside didn't. Soviet doctrine demanded a machine that could fight in an irradiated wasteland. Enter the T-55 in 1958. It looked like its twin, but packed a 580 horsepower V-55 diesel block. Ammunition capacity bumped up to 43 rounds. The real upgrade was the PAZ overpressure system. It sealed the hull, filtering out radioactive dust and chemical gas. Later, the T-55A added heavy anti-radiation lining, creating a true combat-ready nuclear survivor. But its armor thickness remained frozen in 1947. By the 1960s, British L7 105mm guns could punch straight through its frontal plate at 2,000 meters. The 100mm rifled gun hit its absolute physical limit. To crack newer NATO armor, engineers realized they had to throw out the concept of rifled barrels entirely. The 1961 T-62 answered the call. 37 tons of steel. It mounted the 115mm U-5TS gun. This was the world's first production smoothbore tank gun. It fired fin-stabilized steel darts at 1,600 meters per second. Kinetic energy simply punched through anything NATO fielded. The catch? A clunky casing ejection system. After every shot, the gun had to automatically elevate to spit the hot brass out a rear hatch. The gunner lost his target alignment every single time. Hauling these 22-kilogram shells exhausted crews fast. To lock a steady fire rate and shrink the turret, Soviet designers made a ruthless choice. They fired the human loader. The early T-64 was a complete reset. 38 tons. It started with a 115mm gun, quickly upgraded to a brutal 125mm on the T-64A. Crew size dropped from 4 down to 3. An electromechanical autoloader slammed shells into the breech, locking in 8 rounds per minute. It also debuted composite armor, layering steel and fiberglass to neutralize shaped charges. But this complex machine came with a staggering price tag. Its compact 700 horsepower opposed piston engine was a maintenance nightmare, breaking down constantly during early field trials. The Soviet command pumped out over 13,000 units, but realized the tank was too expensive for total mobilization. They desperately needed a cheaper, rugged alternative, sparking a bitter rivalry between design bureaus. Enter the T-72 in 1973. 41 tons. It kept the massive 125mm gun, but ditched the delicate engine. It ran on a brutal 780 horsepower V46 diesel. It was built for one thing: mass mobilization. They simplified the autoloader and stripped out expensive early composites. Soviet factories pumped out over 25,000 units, flooding the Warsaw Pact. But that cheap autoloader held a dark secret. 22 propellant charges sat exposed in a flat carousel directly beneath the crew. One penetrating hit triggered a flash fire. The blast wave blew the 12-ton turret clean off the hull. While the T-72 filled the cheap ranks, elite Guards tank divisions demanded more. They wanted a premium hunter-killer to spearhead a hypothetical dash to the English Channel. It needed raw, terrifying speed. The T-80 hit the dirt in 1976. 42 tons. It ditched diesel entirely for a 1,000 horsepower aviation gas turbine. It sounded like a jet fighter. This turbine pushed the tank to 70 kilometers per hour. It earned the nickname the Flying Tank, out-accelerating every NATO counterpart off the line. But that speed came with a massive logistics tax. The turbine drank fuel. A T-80 burned through its internal tanks up to 3 times faster than a diesel T-72. Then the Soviet Union collapsed. Defense budgets evaporated overnight. The newly formed Russian Federation couldn't afford a thirsty jet-powered tank. They needed a cheap hybrid built from the ashes. The T-90 rolled out in 1992. 46 tons of steel and composite. Born in the late Soviet era as Object 188, it married the cheap, reliable T-72 hull to the elite T-80 fire control system. It packed the Storer 1 active protection system. Those glowing red eyes weren't just for show. They broadcast infrared signals to jam the guidance systems of incoming anti-tank missiles. On top of that, it wore Contact 5 explosive reactive armor, heavy steel blocks designed to detonate outward. This blast physically snapped the penetrator rods of NATO kinetic rounds before they pierced the base hull. But the T-90 couldn't escape its Soviet DNA. The deadly ammunition carousel remained, meaning a clean hit still guaranteed total destruction. Designers knew this classic layout was a dead end, forcing them to revive a terrifying, top-secret prototype. Enter Object 477, codenamed the Hammer. Conceived in the late 1980s, 50 tons. It mounted a terrifying 152mm smoothbore gun. Soviet engineers finally broke the curse. They moved all 3 crew members down into the heavily armored hull. The turret became an unmanned weapons module, pushing crew survivability to absolute maximums. But that 152mm gun created a mechanical nightmare. The 2-piece shells were massive. The autoloader had to pull them from 3 different rotating drums, causing constant jams and catastrophic feed failures during trials. The Hammer was simply too complex. When the Soviet economy flatlined, the expensive project was quietly buried. But rival engineers in Leningrad had a cheaper, brutal backup plan to field that exact same gun. The Object 292 emerged in 1990. 46 tons. Leningrad engineers took a standard T-80 hull and strapped a colossal 152mm LP-83 gun to it. This was brute force engineering. The gun produced 50% more muzzle energy than the standard 125mm cannon. It could punch through a full meter of solid steel armor at 2 kilometers. But physics always collects its debt. The recoil was violently excessive. The sheer kinetic shockwave stressed the modified chassis to its limits, threatening to warp the turret ring during intense firing trials. Then 1991 hit. The funding vanished. But rival engineers in the Ural Mountains refused to let the 152mm dream die. They realized they needed a completely new, heavier hull to handle that firepower. Object 195, later called the T-95, was born in 1988. 60 tons. It kept the 152mm gun but stretched the hull to 7 road wheels to handle the massive weight. The layout was revolutionary. It locked all 3 crewmen inside a sealed titanium capsule in the front hull. The turret was completely unmanned. This physically isolated the humans from the explosive ammunition. But hiding the crew deep inside meant they couldn't just look out a hatch. They relied entirely on early radar and fragile camera systems to see. During field tests, these delicate electronics constantly failed. A blind tank is just a steel coffin. The project bled money for decades before being officially killed. But while the Urals struggled with cameras, engineers in Omsk tried a much simpler trick to fix the ammo problem. The Black Eagle broke cover in 1997. 48 tons. Omsk engineers took a lengthened T-80 hull and mounted a radically new, flattened turret. They finally ditched the floor carousel. Ammunition was moved into a separate armored bustle at the back of the turret. If hit, blowout panels directed the explosive blast upwards, safely away from the crew. But the timing was brutal. The manufacturer went bankrupt. The tank shown to the public was actually a hollow mock-up built on a standard chassis. It never fired a single shot. The Black Eagle died, but its data survived. The military absorbed decades of failed prototypes, cancelled turrets, and bankrupt projects. They merged it all into one final, highly ambitious, clean sheet design. The T-14 Armata broke cover in 2015. 55 tons. It carried the new 125mm 2A82-1M smoothbore gun. It finally perfected the Object 195's dream, an unmanned turret up top. All three crewmen locked inside a fortified capsule below. It brought extreme crew survivability to the modern era. But the sticker shock was fatal. Packing stealth, shaping, active radar, and a complex X-shaped engine pushed the unit cost to nearly $4 million. Mass production stalled. The grand high-tech fleet never materialized. Instead of building the future, engineers were ordered to cannibalize the past, forcing a massive upgrade program for the aging T-72. Enter the T-72B3 in 2011. 46 tons. It wasn't a new tank, but a massive factory rebuild of 1980s hulls, packing a standard 840 horsepower engine. The real upgrade was the Sosna U thermal sight. For decades, Soviet tanks were blind in the dark. This system finally gave gunners clear thermal vision out to 3,500 meters at night. But engineers left the transmission untouched. The tank could charge forward at 60 kilometers per hour, but its reverse speed was locked at a miserable 4 kilometers per hour. It couldn't retreat from ambushes. While the B-3 filled the ranks cheaply, the military still needed a premium spearhead. They took the Armata's tech and grafted it onto their most reliable chassis. The T-90M Proriv began deliveries in 2020. 48 tons. It completely discarded the old Soviet cast dome for a brand new multi-layer welded turret. It wore next-generation relict armor. It also finally tackled the ammo problem. Engineers added an armored bustle to the turret rear, physically moving the extra shells outside the fighting compartment. But it was a half measure. The infamous floor carousel still held 22 ready-to-fire rounds directly under the gunner's boots. The core structural flaw of 1973 lived on. With Armata delayed and the T-90M expensive, command looked north to the freezing Arctic. Diesel engines choked in sub-zero winters. They had to bring the old flying tank back from the dead. The T-80 BVM rolled out in 2017. 46 tons. Engineers pulled rotting T-80 hulls from deep storage and dropped in an upgraded 1,250 horsepower gas turbine. It was built for the Arctic. At minus 40 degrees, a diesel T-72 takes 45 minutes to warm up. The BVM's turbine spools up and drives off in under 3 minutes. But its internal geometry was a death trap. Its specific autoloader stored the propellant charges vertically. This created an explosive ring that stood higher inside the hull than the T-72, making it an easier target. From the cramped T-54 to the ambitious Armata, Soviet and Russian tank design chased a ruthless balance of mass, firepower, and cost. The steel evolves, but the doctrine never ends. Leave your verdict below.